Number 6, same idea. You're not allowed to have I in the denominator, but this denominator is a binomial. So just multiplying by I over I will not do the trick. You need to multiply by something called the conjugate. The conjugate of 4 minus 9i is 4 plus 9i. So conjugate is exactly the same except the minus turns to plus. Or if it was already a plus, you'd change it to minus. So the middle term, or the middle sign, changes to its opposite. And you multiply the top and bottom by that. On the top, we're going to put this in parentheses and distribute, and that gives us negative 28i plus 7 times 9 is 63i squared. On the bottom, we would do the FOIL method, first, outer, inner, last. But if you remember from the lesson, when you multiply conjugates, the outer and inner terms always cancel. In this one, you'd get 36i and negative 36i, which cancel out anyway. So to save time, a shortcut, all you have to do in a problem like this is multiply the first, that's 16, and the last. Negative 9 times negative 9 is negative 81. I times I is I squared. Now, as I've said a few times, well, I guess in the last video, if you ever have I squared, you must make it negative 1. So this is negative 28i plus 63 times negative 1 over 16 minus 81 times negative 1. So that becomes negative 28i minus 63, right? Negative 1 times 63 is negative 63. On the bottom, it turns into 16 negative times negative is positive, so plus 81. And you can combine that, 16 plus 81, so you get negative 28i minus 63 all over, what is that, 97. That should be your answer, and that is D. Number 7, simplify square root of 98. So 98 is not a square number. If you want to simplify it, one method is to make a factor tree. 98 is an even number. You can divide it by 2. 98 divided by 2 is 49. Grab a calculator if you need to do this math that way. 49, of course, is 7 times 7. So we look for pairs. We have a pair of 7s. So the square root of 98 is going to be 7 squared. And then we have that extra 2 right there. And now just keep in mind that a square root and a square cancel each other out. That means you can simplify out the 7, but you cannot simplify out the 2. It does not have a square, so it stays under the radical bar, the square root bar as it's called. And so 7 square root of 2 is the answer. That is A. Number 8, solve by taking square roots. So I went ahead and copied the problem off to the side so I have room to work it out. To isolate V, of course, you need to take the square root. So a square root and a square cancel each other out, and you need to do that on the other side. So we get V equals. Now, a couple things are going on here. Whenever you square root to solve an equation, you have to put a plus minus down on your answer. This is what we call the square root property. Second, when you square root a negative number, you get an imaginary number. So the square root of negative 18 is going to work out to be an imaginary. Finally, 18 is not a square number. So what we're going to do is kind of what we did on the last problem. 18 breaks out down into 2 times 9 and then 3 times 3. We do have a pair of 3's, so that's 3 squared and an extra 2. The one with the square simplifies out from the square root, so the square root of 3 squared, you just bring out a 3. The 2 does not have a square, so it stays radical 2, or square root of 2, however you want to say it. So that 18 turns into 3 radical 2, and then normally you put the 3 in front of the I, so plus or minus 3i radical 2, which can be written 3i radical 2, comma, negative 3i radical 2, and that is choice C. Number 9, same problem, same idea. Going to subtract 6 on both sides. Oh, well, this is kind of dumb. Negative 12 minus 6 is negative 18, and now it's the same problem as that problem. Okay, I didn't realize that. I should have made this one a little bit different at least, but we do the same process, plus or minus I. What's the square root of 18? Well, we just figured that out. It's 3 radical 2, so same answer, positive 3i radical 2, negative 3i radical 2. All right. Silly mistake, that one kind of got by me. When you take the test, 8 and 9, 8 on the test will be like this number 8, 9 on the test will be like this number 9, but they're not going to be like each other. So keep that in mind. Number 10, find the discriminant of each quadratic equation, then state the number and type of solution. So the discriminant has a formula. It's b squared minus 4ac. In this problem, a is -1. That's the number in front of k. That negative sign, you treat that like a -1. B is also a -1. There's a -1 there. And c is 6. So I need to plug those numbers into that formula. So -1 squared minus 4 times -1 times 6. If I square -1, I get +1. -4 times -1 is going to be +4 times 6 is 24. 1 plus 24 is 25. So the discriminant is 25. That means it could be A or C. What does that mean? If you go back to the lesson, anytime the discriminant is greater than 0, meaning positive, which in this case 25 is a positive number, there are 2 real solutions. So that's something straight from your notes. There it is. That does not mean number 10 on the test will be 2 real solutions. All it means is you're going to have to do the discriminant formula. The one on the test might turn out to be less than 0 or equal to 0 or something like that. There are a few more examples which I'll get to in the next video.